All right, let's jump right in. When you think about railways, you probably picture tracks and trains, right? But there's something else, a vast hidden information superhighway running right alongside them. And today, we're going to pull back the curtain on this digital backbone. And our guide, believe it or not, it's a single, pretty dry-looking maintenance report.
Yeah, I know what you're thinking. A railway maintenance report? How exciting can that be? But what if I told you that a document just like this holds the key to understanding the health, the challenges, and the absolutely incredible untapped potential of a critical piece of national infrastructure? Well, that's exactly what we're about to find out. So what we've got here is a fiber utilization report from India's Bareilly railway section. This thing gives us a rare, ground-level snapshot of, well, the nerves of the country's communication system. So let's get into it.
Okay, first things first. Before we can really understand the story this report is telling us, we kind of need to learn its language. It's filled with some technical terms, but honestly, they're pretty simple once you break them down.
So, the star of the show here is the OFC, which stands for Optical Fiber Cable. This is the actual physical cable that's laid right alongside the train tracks, and it's packed with these tiny strands of glass. And each single one of those strands or fibers can carry a massive amount of data using light. It's pretty amazing stuff.
Now, this report tells us we're dealing with 24 fiber cables. And honestly, the best way to picture this is to think of it like a 24-lane superhighway. Some of those lanes, they're reserved for the railway's own stuff, signals, communications. Then other lanes are leased out to telecom companies, and a few are supposed to be kept empty, just as spares.
Okay, now here's a really crucial term you'll see in the report: break fibers. If we stick with our highway analogy, these are the lanes that are just closed for repairs. They're damaged, totally out of commission, and they can't carry any traffic at all. This number is a direct measure of the network's problems.
And on the flip side, we've got spare, usable fiber. These are the empty, perfectly paved lanes on our highway. They're not being used by the railway, they're not leased out, but they are 100% functional. This number? This represents pure, untapped potential. All right, so now that we've got the lingo down, we can use it to give this network a full-on health check. Let's dive into the actual numbers from the report and see what they really tell us about the state of this infrastructure.
So this table here, it's basically a simplified look at the core data. You can see 6 different routes in the Bareilly section. And for each of those routes, the table breaks down how all 24 fibers in the cable are being used. Are they in use? Are they broken? Or are they spare? Just take a quick look at that break fibers column. The numbers you see there, they're pretty telling. They kind of hint at the big story we're about to uncover.
So when we add up all 144 fibers across all 6 of these sections, this is the big picture we get. And the split is, well, it's fascinating. You got about 46% in use, which makes sense. A solid 17% are spare and ready to go. But then look at that huge orange slice, a staggering 37%. Nearly 4 out of every 10 fibers are just broken.
Here are those exact same numbers, just shown in a different way, which can sometimes make it clearer. You've got 66 fibers actively working, and we have 25 perfectly good spare fibers, which is great to have. But then right there in the middle, that's the real showstopper. 53 fibers are completely out of action because of damage.
53. Just let that number sink in for a second. Across just these 6 short railway sections, there are 53 broken lanes on our information superhighway. That is more than 2 entire 24 fiber cables worth of capacity that's just gone, wasted.
But, those big overall numbers don't actually tell the whole story. The health of this network, it isn't consistent at all. To really get what's going on, we need to zoom in and compare a couple of specific routes. And wow, what a contrast this is. On the left, you have the route from Andla to Chandusi, and it is in rough shape. Get this, 20 of its 24 fibers are broken. That leaves zero spares. It's basically running on fumes. But then you look to the right at the Rampur to Bareilly section, it's so much healthier. Only 2 broken fibers and 5 spares ready to be used. This shows the problem isn't everywhere. It's localized and varies dramatically from one section to the next.
So, after decoding the report, digging into the data, what does it all mean? What's the big takeaway from this deep dive into this hidden network?
Well, this whole analysis really leaves us with 3 key things to remember. First, a huge portion of this infrastructure is just broken and needs serious repair. Second, even putting the broken parts aside, there's a significant amount of capacity, all those spare fibers, that are just sitting there completely unused. And third, the condition of the network is not uniform at all. It's really a patchwork of healthy sections and really unhealthy ones.
Ultimately, what this all comes down to is a simple truth. The high number of broken fibers, that's a huge challenge, no doubt. It needs to be addressed. But the combination of those broken fibers that could be fixed, plus the existing spare fibers, well, that represents a massive opportunity to boost connectivity and support India's digital growth, all without having to lay a single new kilometer of cable. And that really leaves us with this one final thought. We've uncovered this incredibly valuable hidden asset that is, frankly, seriously underperforming. So the real question isn't just about fixing what's broken. It's about strategy. How can an entire system like this be managed, repaired, and leveraged to finally unlock its full potential? How can it help bridge the digital divide and really power the country's future?